Hello, my name is Stefano. By the way, I've done a lot of R&D tax claims in the past, so it's really painful. Producing the documentation is really, really painful. So, so today I want to talk to you guys about some of the lessons about that I've learned about running machine learning models and AI techniques in production. So you see my picture there. I always keep a picture when I was younger, so it's better. But so I actually, when JR Academy reached out to me, I was still working at Rokt, but I've finished recently, and I'll be joining TikTok in a week's time. So most of my experience comes from obviously my Rokt time, as well as time at News Corp, about running machine learning models in production. So these are some of the numbers we're looking at. Obviously, at Rokt is a machine learning company, so we did a lot of that. I was responsible for the data platform specifically. Now, one of the things that I found really daunting when I started looking into the ML space is that you need to look at machine learning as a series of tools to add value for the business, of course. But it's not actually so obvious to see what should you use for what. So I'm going to try and give you in 15 minutes an overview of some of the tools that are mostly used. And hopefully when you go home, you'll be able to play with some of them yourself. Its documentation online is pretty bad, but I think it's worth looking at this. Obviously, always start with a very simple definition of machine learning, right? So we want to analyze a lot of data and learn and make informed decisions. I like to call it make informed, educated guesses. So one of the big differences with traditional programming is that when you program something, for example, I'm going fast, so I won't bore you for too long, but let me know if I'm too fast, right? Okay? So in a traditional programming sense, for example, if you work for a quant trading company, most quant trading companies still nowadays use rule-based systems. The rules are kind of baked into your code. And so what you do is that you deploy the code and you will try and do some trades. But with machine learning, things are a little bit different. So the rules are determined at training time by your models. So your code has no rules, and the rules come from the training, right? It's just a very interesting difference here. Now, when you look at machine learning in general, when you start any machine learning 101 course, you see that they always start saying, hey, you got shallow deep learning, there's classification, regression, supervised, unsupervised. However, I want to talk to you guys about the stuff that is highlighted in yellow today, maybe touching on the rest, and there's a reason for it. So, first of all, the vast majority of problems that you guys will encounter if you work for any company that's got a database and wants to use some machine learning and some structured data is you're going to work with a classification problem. So what does it look like? For example, all right, so you have a database with a table like the following that I have brazenly copied from the internet. But the idea is that you want to use the information you've collected to determine the default probability of a customer. Maybe you don't want to offer them, a credit card or a home loan. Now, what you do is, in a nutshell, when you're doing a classification problem, you use your past, your history, when the labels the one in gray. And then obviously you want to try and determine a relationship between the features on the left-hand side and what the outcome is going to be. So that when you see someone with a high income that is a homeowner, less than 40, you will guess that he may not default. This is just an example, of course. When you look at classification, there's usually, in any course, they always talk about spam detection, so I always put it there. Nobody is writing an email kind of spam detection system, though. Most of the time, you want to build a recommendation system. Recommendation systems come in all sorts of shapes and forms. Obviously, my time at Rokt, it was e-commerce, so I can think about 10 different types of recommendations you can have. You can, for example, knowing the behavior of a customer, you can try and predict if they're going to drop off and not pay and not complete the purchase, for example. You may want to predict that they're going to use a certain payment method versus another. These are just some of the examples. When you, for example, you log into Canva, like I did to make this presentation, you would want to see not 20,000 different options. You want to see the options that you're more likely to use. So if I've only used presentations, I would love if Canva was smart enough to show me, hey, maybe you want to make a presentation today. They don't do it yet, but soon they will, I was told. But this is some of the examples. So as you guys enter, if you haven't already entered your career in software engineering, you will be faced with situations where the business is saying, it would be great if we could do a recommendation system of sorts. Now, it turns out, so I've already covered this. So the first learning is obviously that many businesses' problems tend themselves to be a classification of a structured data with a database. But it turns out that when you go and look online and say, okay, I want to learn how to do classification, structured data, you have a lot of options there. And obviously they always start with the first two. But in practice, the truth is nobody uses them. So it's really good to learn them, but then in practice, I mean, linear regression is used in some areas, but only when you're really, linear and polynomial regression is when you're really trying to predict phenomena that are from physics, where you can actually draw a curve and say, hey, actually this curve is gonna match. Most of the time, nowadays, classification problems are either solved with decision trees or gradient boosting machines, or using deep learning techniques. Now, I want to talk about these decision trees because a lot of people think about AI, they talk about deep learning is cool, etc. So, how many of you have ever heard of Kaggle.com? Yeah, okay. So Kaggle bought by Google, I think a few years ago. If you look at this, this is the most recent kind of graph that I found. You will see that the most successful models are either neural networks, i.e. deep learning, or they are gradient boosting machines. So these gradient boosting machines, even though they have been relatively, they leverage knowledge that has been existing since the 1980s, 1970s. The latest versions are from around the year 2012 onwards. And they work quite nicely, but what makes it really easy to use is that they actually produce graphs like the following. So they will create a decision tree that usually is actually, if you look at it, is actually binary. But in this case, this is a nice kind of example to show. But they would just basically make decisions by deciding what are the most important features. And then, obviously, on your lift node, you got your outcomes. So they're very easy to understand what they do. Now, let me take a step back on this. If you think about the traditional machine learning techniques, there's a concept of, if you guys have ever heard of AI winters. And the fact that, obviously, people thought in the 1980s that we're going to create intelligent machines, etc. So in terms of popularity, you get these kind of waves I've drawn in blue the traditional world. You will see that from 2015 onwards, the popularity of deep learning is increased dramatically now. If you think about what you can do nowadays in terms of generative AI and a lot of other ChatGPT, LLMs, etc., it all comes from deep learning, right? Google was, and still is, one of the companies that actually has invested the most and pioneered some of that. And actually, they have demonstrated you can do a lot with it. However, what people don't tell you most of the time is that if you look at the cost and the complexity of running deep learning models in production, you will see that I've drawn there in green. It is 10 to 100 times more expensive than traditional machine learning techniques. And what happens is, most of the time, and I've seen it with different companies doing the same mistakes. So setting up a gradient boosting tree to try and do predictions, it's a very trivial thing to do. You can get up and running within a day. It'll give you a accuracy that, let's say, from the 80s to the 90%. But what happens is the business always wants to improve, and so they'll come to the data scientist and say, how can I get any better than that? And so after a bit of feature engineering, they'll usually say, well, if you really want to make a jump to the next level, you got to go into deep learning. The problem with deep learning in general is it's very expensive. It works well when the problem complexity is quite high, i.e. when you are trying to predict something, and that prediction comes from a series of complicated steps. So typical example is if you want to do image recognition, it's a very complicated steps, a series of complicated steps to understand it. I won't delve into the details, but if you want to predict if someone is going to drop out of a funnel or not, that's not complex problem. Also, you need a lot more data. And deep learning really thrives on unstructured data. So the truth of the matter is, most of the time, you don't really need deep learning, unless you want to play with ChatGPT. I'll cover it in a second, and I think Sam has got a presentation. And there's some use for it. But most of the time, if you actually just do a GBM classifier, cat boost, XG boost, LightGBM, there's a few, and you can find a lot of tutorials online. You can actually get a really good result that it's easy to train and it's easy to run inference on, i.e. predictions, and it costs you nothing to run it. You can just chuck it as a library into your executable. Now, if you don't believe me, maybe some of you have seen this. Netflix used to run a prize, 2009, 10, and 11, about recommendation systems. And I think for the 3 years that it was run, a GBM classifier won all the three years in a row. Different types, of course, customized. But that's if you guys want to walk home with one learning, is don't give up on traditional machine learning just to jump on deep learning. Of course, I covered it before. There's a problem. Yeah, can I use deep learning? Yeah, you can create a deep neural network. It is way more complicated, way more prone to overfitting, i.e. to try and predict stuff, but actually not really understanding the patterns and just copying over basically your training data. But also another area where a lot of people get stuck, even a lot of machine learning data scientists, is unless you have a truckload more of data. When I say truckload, I mean more entries to train on, but also data without many holes. It's very common in your database. You don't have all the information, all the entries are not, for example, you might not have all the information about all your customers, right? And so when you start having a lot of these holes, deep learning you struggle with training with deep learning. It will try to overfit a lot. It won't even perform as well. And also, if your actual underlying problem is actually quite simple, you're wasting time. Now, I've spoken already for a while, so a couple of more things I want to cover. A lot of the time, and I've seen it a few times actually, if you want to start playing around and you downloaded your LightGBM or XGBoost and library, and you want to say, okay, now I want to predict if people are going to drop off or not, or I want to personalize the behavior of your website, imagine. The problem you're going to find is, how do you know if your model works better than what you got at the moment? A lot of companies actually don't even get to the experimentation part, which is quite interesting. They just roll things out in production, and they look at the bottom line of sales. They say, we're selling more, so it must be working, right? The problem is that experimentation capabilities are absolutely needed, and they're not actually that trivial to realize. I guess most of you have heard about A/B testing, right? There's A/B testing tool for UIs. There's plenty of them. For ML, not much. There's some libraries you can use. Basically, 100% of my experience, companies have built their own tooling. Ultimately, you collect data and then you run some statistical analysis on it. That's what an A/B test is. But the bottom line is, even on a trivial A/B test, and I've seen this multiple times, right? I won't mention which company, but I've seen it multiple times. An A/B test starts at a certain point when you roll out a new model. And at some point, we are very lucky in this case, right? You see, the new model has a higher accuracy consistently than the previous one, right? This is just an example of some of the tricks that happen with ML. However, you turn off the model here on the second line. However, if you actually had left it on, you will notice that if a time now is at the end of this curve, your old model actually would outperform the previous, the newer one. Now, a lot of the time, what companies do is this. They just turn off your model, all right? And so they say, well, we made an improvement, 5% here, 10% there. And you keep on doing it. However, the average of this line never grows, all right? And this is just an example of how it's actually not that trivial to handle this. So there's ways to solve this problem. You need to do holdouts. There's things that I don't want to bore you with. But there's a way to solve this. It's just a lot of companies don't do it. But this is just an example of how it can get tricky on this. So experimentation, you need experimentation capability. Otherwise, you don't know. You just, you're just guessing. And guessing is usually not a good thing, especially when it comes to ML. Because you never know if what you deployed is actually better than what you had before. One more thing. Now, I said I wasn't talking about deep learning. I think there's a presentation on this, so I'll touch briefly. There's one area of the generative AI or LLMs which I think is going to be really important. And if you want to have a look at it because I think it has a lot of applications. So you guys know that if you ever use ChatGPT, you enter some text and ChatGPT will return you back some other text. But the way it works under the hood is that your text is tokenized and then converted to what they call embeddings. Now, it took me a long time to understand what embeddings are, because if you Google embeddings, you find all sorts of weird definitions. But I'm gonna try and give an understanding. So tokenization is a pretty trivial concept, i.e. you break down your text. All right. So for example, you tokenize by word. Now, if you ever use ChatGPT, it doesn't tokenize this way. All right. So there's a tremendous area of study on how to tokenize, because there's reasons for the way it's done, but words that are similar may share some tokens, for example, so it doesn't do anything like that. If you want to go online, you go on ChatGPT and just say, return me back to tokenization. I think there's an API for that. I'll show you how it does it. But the most interesting bit is there is actually there's machine learning models that actually are already being trained, like ChatGPT offers it as an API, so you can say, return me the embeddings. But you can even use open source one. And one of the things you can do is these embeddings are just series of numbers, like vectors of numbers, but they have some interesting properties. For example, and this is actually was just found by mistake. So if a vector of a man is to a woman, represented, imagine that it's a two-dimensional vector. Okay, so we're drawing on paper. You can see that if you actually get a vector of a queen, and then you remove the woman from it, you actually get the king, the vector of a king. So there is, what this means really is that these numbers, if done properly, they actually capture the essence of the meaning of a word, all right? So there's another example that I'm going to give, but the idea is if you can do that, what you can do is you open up the opportunity, let's say you open up the floor for having sophisticated similarity search capabilities. I was already talking before. For example, if you do a Google search now, there's a high chance that it will automatically, if there's not enough direct hits on your keywords, it will actually fall back onto similar words with the same meaning. And the way it does it is basically using this setup. Google has been doing it since 2018. In fact, Google has open sourced a model called BERT. You can download it, right? And it's trivial to run the embeddings and a tokenizer, and you get these embeddings. Now, look at how interesting this is. A bank vault and a bank robber are actually not that different from each other if you look at the numbers, right? They're kind of close, but the river bank is very different. So what it tells you is these numbers, these kind of vectors, are able to capture the essence of the meaning of the words. And they're actually able to capture the fact that bank is used in different ways. This is a typical example you can find online. But it's actually quite interesting. Once you can do that, first of all, you can build accurate translations. And that's what BERT was designed for. But you can use these embeddings and do search, but I won't spoil what Sam's going to present in a minute. So, so stay tuned. NLP, natural language processing, will become a game changer for search. You're already seeing it, people saying, well, ChatGPT will replace Google. Not exactly like that, but it's definitely something that people need to look at. So, just to recap, and then I finish up. So, classification problems are the most common problems in the business realm. GBM classifiers are cheap. And cheap, accurate, easy to get running. However, you need to have experimentation capabilities to know what you're doing. And if you're really interested in generative AI, NLP, etc., look at it from a perspective of search. That's what's going to be the biggest improvements. That's it. Good.